right. Good morning, everyone. This is day 5 of writing a TCP/IP chat application. I didn't think this series would actually go this long, but I'm a bit of a talker, and I'd rather explain things as I go through. So that's one reason why this is taking longer than it might take if you were just sitting down and banging out the code. Let's see. So start off with a shout out to my GitHub sponsors. You guys are awesome. If anyone has any questions, go ahead and put it into the chat. Hello there. I see if it's Freddie, if I'm pronouncing that right. There is a bit of a delay on the chat. Keep that in mind. 15-20 seconds or something like that before I actually see it. And that's assuming that I actually look over at that screen because it's kind of off to the side. But yeah, that's the best place to put your questions. And so this is day 5. I want to go over just kind of like an overview. All right, Freddie, I got that right. Awesome. I want to go over an overview of what we have currently in our solution. And one thing that I was thinking about, during the day yesterday, I actually have one thing in the solution that's very important to have, but I didn't call it out explicitly. So I'm going to talk about that a little bit. Just because that's a common mistake when you're doing plain old socket programming, and if you aren't building up all these layers like I'm doing, trying to keep it a little cleaner, there's something that you can easily miss. So I want to call that out explicitly, and then talk about where we're going, what we still have left to do, which is still quite a bit. So this is going to go on a few more days. Also, I will not be here tomorrow morning. The next session will probably be Saturday morning. Yeah, my son has a doctor's appointment tomorrow morning, so I just won't be here on the stream at all tomorrow. So let's go through what we have currently, and I'm going to switch over here to, you guys can see my code. This is the code that's currently on GitHub. This is the end of day 4 here. And we have, I'm looking mainly in this chat API, this like shared library that I created yesterday. And we extracted out all of these protocol level things, right? So I'm going to describe kind of like conceptually what we have here. We have, so first off, we're given a socket, which the abstraction is a stream of bytes, okay? Because when we have a socket, I know I've said this 10 times already, and I'm going to keep saying it, but your abstraction for a socket is a stream. It is not messages. Sockets give you a sequence of bytes, and that's it. They don't give you any kind of message delimiters. You have to build that yourself. So we have this socket, which is a stream of bytes abstraction. And then this pipeline socket that we wrote here is just using System.io pipelines. So now we have a socket that is a pipeline abstraction. Well, it's still a stream of bytes, right? We just moved from socket APIs to pipelines. It's still a stream of bytes. That's still the same abstraction. And all we have here is a couple of like processors or whatever you would say, like 2 main loops essentially. We have a reader and a writer that just translates between the socket API and the pipelines API, but it's still a stream of bytes. That's what we're dealing with at this level, at the pipeline socket level in our code. Then we've got this next level up here. Now this one right here, this one does all of our protocol parsing and serialization. The pipeline socket is very generic. You can use that with any kind of, reading and writing to a socket. This one, the chat connection, is, so this one is where our protocol starts coming into play. This is where we start defining things like we're using length prefixing, and these are our message types and that kind of thing. Now, right now, it's just doing some parsing, some serialization. We've got our write, which is not thread safe, as the comment says. that just writes out a single message to the pipeline, to the underlying pipeline. And then we've got this handle pipeline async, which again right now has the processing like hard-coded in here. These are going to be the first things that we change today. But it's got the processing right inside of this method that just reads, it parses, with this parse messages, it parses the incoming messages coming out of the socket, out of the pipeline, and then processes them immediately. Now what we're going to be doing today, I think, we're going to do just a little bit of clean up something that I probably should have done yesterday. And then we're going to change this type from being like, here's how you, from having all this integrated knowledge, we want to separate out all the actual processing of the messages and move that back into the server and the client. And what we're going to end up here with this chat connection is really just a layer of a stream of messages. That's the goal. So we have a stream of bytes coming from the socket. Freddie says maybe I didn't push the latest changes. You're right. Sorry about that. There you go. All right. So what we have right now is a socket, stream of bytes. We've got the pipeline socket, also a stream of bytes. What we're going to do, hopefully today, is take this chat connection, and we're going to make this into a stream of messages. Okay, so it'll have an input message stream and an output message stream. Very similar to stream of bytes, just doing a stream of messages. So one of the things that we kind of did along the way, just because of the way that this API ended up, the way that I wanted this thing to work, when we combined the server and the client code that were reading and writing the socket, one was reading, one was writing, when we combined that into a single, like the pipeline socket, as a side effect, we got something that you actually have to do. And so I want to call that out really explicitly. And that thing is, we are continuously reading on the socket, even on the client side. So, we would have to do that eventually anyway with a chat application, because the client has to listen for chat messages coming in from other clients saying things, right? So we'd have to do that eventually, but I want to really explicitly call that out, because even if you have a protocol where you're not expecting to ever receive any messages, you still have to read from the socket, and you have to read from the socket all the time. At least I think that's the easiest way to do it. And the reason comes down to error handling, which is something that I hope to get to today. I'm not sure if we will actually quite get that far in an hour, but that's error handling is something I want to get to today. But just to give an overview of why you have to read all the time. So I've talked before about how a socket is a stream abstraction, and how really it's more correct to think of it as two unidirectional streams than a single bidirectional stream. So like the network stream makes it look like a single bidirectional stream. Actually underneath it's two different unidirectional streams. Now, the reason that that's important is that there's also operating system buffers involved. So we've talked about, I know I mentioned this yesterday or the day before, about how a write actually happens. So we've got a message, we're going to serialize that, it goes into our pipeline, then we've got some code, the pipeline socket, that reads from the pipeline and writes it out into the outgoing message stream on the socket. Now, what actually happens here is the socket has its own operating system level buffers. So it has an outgoing buffer. And then the socket write actually just writes into that buffer. And then you've got the outgoing buffer on one side of the socket, and you've got an incoming buffer on the other side of the socket. So you've got a send buff and a receive buff, as they're called in the socket terminology. And when you read data out, you're reading from that. When you're reading data from the socket, you are reading from that received buffer. So the buffer transfer is what's interesting here, because that happens without any application involvement. So the computer, the OS on one side, takes its send buffer, whatever's in that send buffer, and it sends it to the other computer's receive buffer. And this is where things like TCP handles all the things like, well, what if packets arrive out of order? Or what if there's duplicate packets? Or what if there's a missing packet? And it also has acknowledgements going back and forth, well, going back, to let the other side know, okay, yep, I got that. I've gotten your data up to this point. And there's also flow control involved. So if you don't get the ACKs sufficiently, then you know, well, the other side's buffer must be getting full. I need to slow down. So all of this is handled at the OS level and the TCP level. And we actually don't have any insight into that. From the application level, we don't actually know. We just know it got to the output buffer, and that's it. The write is actually considered complete at that point. I'll come back to that in just a minute. So I want to talk a little bit more about that. But the point I'm making here is that if there's a problem, right? Well, actually, let's talk about that right away. About the write being complete. I think I cover this in socket operations, maybe. Okay, so I do mention it here. So when you're doing a socket write, you know, the actual, what is it, WSA send? Boy, it's been a while. But essentially the socket.write. When we're actually calling at the lowest level, and we're doing this pipeline to socket, and we're writing this out into the, socket.send. That's send async. When we're actually calling this send, this can complete, right? This await can actually complete successfully as soon as those bytes are written to the OS buffer on the local machine. So because that, you know, a lot of people read about TCP has acknowledgement and retries and all this stuff, but it's important to note here that your write will actually complete before the remote machine even sees it. Okay, so it's not including that idea of the acknowledgement and the remote machine has the data. That's not what the write completing actually means. It just means it's written locally to your local machine. So a successful write may complete before the remote operating system acknowledges that the bytes were received. And I think I go into this a little bit more here. Blah, blah, blah. Yeah, so here I talk a little bit about how the write actually works. And it usually, you know, we're doing small packets back and forth with a chat application. Our write applications, or our write calls, our send calls, are always going to complete pretty much immediately with this example application. But it's also possible for, if that remote OS buffer is full, then our local buffer may also be full, our send buffer may be full, and at that point then that's when the send async actually doesn't complete immediately. So really in actual real world usage of a chat application, this send async is actually going to always complete synchronously. I don't think it would ever have a situation where it would actually be asynchronous. But it could, especially if you're sending lots of data. And I was thinking, you know, if you have a chat application, fine. As soon as you like add a message like, oh, now we're gonna like send an image, you know, or something like that. Well, that's a lot more data. That's the point at which, send async may behave asynchronously. So you always assume it can be asynchronous, and this code does assume it can be asynchronous. But so the whole point of what I'm saying here is this send, or this socket write, completes when the data is just copied to the outgoing OS buffer. Now the problem is error handling, right? Because the outgoing buffer is going to eventually get to the receiver. with TCP/IP, or it's going to have an error. With TCP/IP, you are guaranteed one of those two things. When you write some bytes into your stream, those bytes will either get to the destination and they will be in the correct order, or you will be notified of an error. The protocol itself actually guarantees that, the TCP protocol. It's what's called a reliable protocol for that reason. UDP does not, right? This is one of the big differences between TCP and UDP. UDP, you can send something and if there's some kind of error, it'll be like, you don't even know that it happened. With TCP, you're guaranteed the remote side will either eventually get the data. It might take some retries. TCP handles retries and all that. But you are guaranteed that either the remote side will get the data or you will be notified of an error. Now, the question is, how does that error notification happen, right? There's no events on the socket that say, hey, this socket had an error. We couldn't actually send your data. And that's one of the reasons, or that is the reason why I recommend constantly reading from the socket. Because what actually happens here is you have a socket that, even though these are two independent streams, there's one socket connection. It is one TCP connection. And in that case where that data sending fails, so you've written the data, right? You've got it's copied into the local OS buffer. Your send is complete. This call right here completes and did not raise an exception. So you continue on out of this and now you're just waiting for more data to come in on your pipeline. You're not actually calling into the socket anymore. Our code isn't going to be doing that at this point. We have sent the message, so that's all we have to do with our socket. So what happens is the OS will try to send that data from its send buffer. It will eventually fail, right? It'll retry several times and eventually fail. The local OS will detect that and say, all right, this socket is no longer in a usable state. This connection is broken. And it doesn't have a way to notify the application of that. So what it does is it essentially makes the socket itself go into an error state. So then any future operations on that socket will result in an exception. So if we call send to send the next message, then we'll get an exception, saying that, which actually means that the last message didn't get sent. Awkward, right? Awkward. I like to be notified much faster than that. So one of the reasons that it's important to be receiving all the time is that you can actually get notifications of those errors coming in from the receive async, I believe. So this code here is actually always reading from the socket, assuming that there's always room in the pipe writer to push that data upstream. Again, this is the what's it called? Back pressure. This is the back pressure situation. But the idea is that we always want to be reading on a socket, and this allows us to detect scenarios like that and know when something fails. Okay. So if we need to have proper error handling, then we have to have continuous reading on the socket. That is the number one easiest way to be notified as soon as possible about socket failures. So I just wanted to explicitly call that out because before we had this pipeline socket type, we had one side doing just writing and the other side doing just reading. And the problem with that is the writing side didn't actually know if its message was going to be received because it wasn't doing that continuous read in order to detect errors on the socket itself. All right, so I explicitly called that out. We're all good. If you're doing low-level TCP/IP programming, just bear that in mind. You have to have continuous reads. All right, so let's look at what we want to do today. That was 20 minutes of intro and just talking. So today, what I'd like to do is, first there's one little bit of cleanup here that, one of the things that I want to do with the parsing, before we split this back out, this to-do right here. I want to make sure that the pipeline has enough room for the maximum message size. And it's because of the way that we're parsing this out of the pipeline. I'm actually keeping all the bytes for the message in the pipeline until the message is complete. You may not want to do this if you're looking at really large messages. But for this application, I'm going to keep it relatively simple. So what I want to do here is I have to make sure that we have, this is max message size, here it is. So this is coming in as a parameter now. And what I want to do is make sure that the pipeline has enough room for this. So, yeah. So what I actually need to do here is take some pipe options into this constructor and use these when I'm creating these pipes. And we would want, let's see, if we have a unit max message size, just like the other one, I'm just going to do it this way and not allow the caller to make any other pipe options, specify any other pipe options. There is a, oh, right. It's in the parameter here. Yeah, so there is a, what we're looking at is the resume writer threshold. No, the pause writer threshold. Yeah. So the way that pipelines work is they are bounded, as I've said earlier, and they have to be bounded to allow back pressure. So we want them bounded. I think you can actually set this to 0. Number of writes before flush async starts blocking. A value of 0, right? A value of 0 allows an unlimited or an unbounded pipeline. We definitely do not want that when we're dealing with sockets because we want to support that back pressure. So let's see here. The pause writer threshold. This is the point at which, this is the number of bytes in the pipe before flush async starts blocking. Yes, so we want this to be at least our maximum message size. I think if I just set this to max message size, I think, oh, you know what? I'm not sure. Does max message size include the length prefix or not? And I think it does not. Let me check my actual parsing code here. Oops. It should really be called out in my documentation here. If the length prefix is greater than max message size, okay, so we need to add the length prefix to this. So this will be max message size plus 4 for the length prefix. So now I have a, actually the output pipe doesn't even need that. Only the input pipe needs that. Let me, because with the output pipe you can write, you know, part of the message and then the rest of the message, that's fine. We don't care. But the input pipe has to hold an entire message because of the way we're doing our parsing. All right, so I think that would work. I'm not that terribly familiar with pipelines, so I'm going to run this and make sure there's no, you know, parameter out of bounds exception or anything like that. After I clean this up, oh, I didn't. What do we got here? And actually, what I'm going to do, I'm just going to remove this one completely, and we're going to make it a property on this pipeline socket. So the next layer up can actually read that. Yeah, exactly what I want. All right, and then in our chat connection, instead of having our own local variable, this is going to become a property on the pipeline socket. All right. So that should handle making sure that our incoming pipeline has a big enough buffer to always hold our biggest possible message. That makes sense. Let's go ahead and build and run this. I don't have my thing over here. I think I'm going to do the server in the console window. No, it's chat server. All right, so now we've got chat server. Let's run this. It's listening. And we'll run our chat, excuse me, our chat client in the browser, or in the debugger. So we connect. All right, everything seems to be working. Looks like the pipeline constructor accepted that parameter without any complaints. Oh man, why did I close that? Ah. All right, well, okay. So we've got that fixed and we've got that to do. That still needs cleaning up. Where's that to do? Here it is. All right, so this is now done. All right, so that's just a little bit of cleanup that I probably should have done earlier. And a good point for a check-in. Ensure pipeline has enough room for biggest possible message. This is day 5. Okay, so the next thing that I want to do here is I want to take my chat connection, which is this type right here, and I want to let's do the parsing side first. What I want to do is, instead of having this do its own, here's all my messages and handling them all, I actually want to make a, what I want to end up with is an IAsyncEnumerable, I think, of messages to read from. I think. It's been several years since I've done an actual TCP/IP application. So I'm kind of thinking IAsyncEnumerable. They didn't exist last time I did a TCP/IP application. So we will see how well this goes. So I'm going to essentially translate this handle pipeline async into an IAsyncEnumerable, and I think I'm going to do that by way of an intermediate buffer again. Seems like we're adding a lot of buffers here. We've got the actual socket receive buffer, which is getting read into a pipeline, which has its own buffer, and then we're parsing that into the buffer I'm going to add here, which is going to be, let's do a channel, because that's, I think, the easiest way to get an IAsyncEnumerable. So I'm just going to go ahead and add System.Threading.Channels here. I can spell. All right. Now, what I'm going to want here is a channel for incoming messages. So this will be, it's been a while since I've used the channel API. Let me see here. So I've got channel dot, it's like a create bounded. And again, since this is a buffer, it's not a buffer of bytes, but it'll be a buffer of messages. In order to keep that back pressure working, I always want a bounded channel. Okay, I never would want to create an unbounded channel here. So we can do this with, we're not going to need like, the default channel options are never lose data, which is what we want. So all we really have to do is specify a capacity, a maximum size. And it doesn't have to be very big. right? This is going to be the incoming message buffer. So this is for messages that have been parsed, they're out of the pipeline, and we just need to, really just a handful of them. I can say like 4, I think would be plenty. 4 messages that have been parsed, just waiting to be processed. I think that's fine. And this is going to be of type IMessage, since we actually have a message type now. So this returns what? Is it a channel? It's a channel of iMessage, okay. And this is, okay, so we're gonna have one incoming channel, all right? And I expect we will probably end up with an outgoing channel as well. I like that API symmetry. So I'm just gonna double check what we named these things. We named them input and output, so I'm gonna name them the same things over here. So this is gonna be the input channel. So this is for messages coming in to our application. And I'm just gonna do this. And right, so then I'm going to, so this handle pipeline async, I'm going to change this. I'm going to change this so that it will actually just read from the pipeline and write to the channel. So it's going to read from the pipeline, parse all the messages that it can out of that pipeline read, and write to the channel. It's going to do that in a loop forever. This is going to be like another main task, right? So we have several already. We've got ones that are reading from the socket buffers into the pipeline, and now I'm going to take one that, this is already looping here, but I'm going to take this loop, essentially rip off all of this, or rip out all of this, and instead of doing the processing here, I'm going to just put it into the channel. So let's, yeah, that sounds actually pretty easy. We'll just do this and say await input channel, thank you. All right. I never understand why it doesn't show up sometimes. All right, so we've got a channel reader and a channel writer. Okay. I forget these things when I haven't used them in enough time. And then write a sync message. All right, so we're going to write into that channel everything that we parse out from the pipeline. And then we're going to have a IAsyncEnumerable of iMessage input messages. Input doesn't really sound very good there, but incoming? Yeah. Input is more consistent. We'll do input, sure. And I think I can just do this, pull it from the reader, read all async, yes. All right. So now we've got a, now we've got this type. I'm going to rename this because I like what we ended up with this pipeline socket. So we've got pipeline to socket, socket to pipeline, and now we're going to have a pipeline to channel, as we can say. You call this pipeline to channel. Since now it's just copying from the pipeline, doing all the parsing, and then putting those parsed messages into our channel. And I'm going to take this processing code, and we are simplifying on down. So in our server now, we're going to move this processing code back into the server. So I'm just going to do this. We're going to ignore that main task for a minute, and instead we're going to do an await for each. Okay, if I remember how to do this. It's been a while. In our chat connection, that's not a pipeline socket anymore. Should rename that. There we go. All right. Now we're going to read these input messages. And this assumes that there's only going to be one reader, which is a valid assumption, I think. I'm trying to think of a case where you'd ever want multiple readers on a single socket connection, and nothing is coming to mind. I think that the input messages here as a property is fine. So now we can actually do our processing. We've moved our processing out of that chat connection type. Now we do need some kind of like designator, right? So I don't know if we expose that. We do expose it on socket. Okay, that's fine enough. It is. I'm going to be changing that. Actually, yeah. I'll leave it as it is for now, but eventually the chat connection itself will have like, here's my remote endpoint, just in case, because if we're gonna have to handle things like after the socket is closed and stuff like that, and I'm not sure if after you dispose the socket you can still access the remote endpoint. I kind of doubt it. So what we're gonna actually do is copy that when it gets added. Let's do that now. I don't want to leave too much for later, and then I'm going to forget stuff. So our chat connection here, actually our pipeline socket, can have the remote endpoint. I'm just going to add it right on here. So we can do public, what is it, IP endpoint? It is an IP endpoint. And I'm just going to copy this at the beginning here. We know the socket is okay. All right. And yes. So it could be null, and it's may not be of endpoint type. Well, let's see about that. So I'm going to assume it's not null. All right, so we've got our remote endpoint there, and this one, this one copies it at the beginning of right when the socket is connected, and then we're just going to take that and push it down to our wrapped type. And now we have a remote endpoint hanging right off of that was copied at the beginning, so it should remain valid even after the socket is closed. All right. Okay, cool. Now that is much better. All right, so what I'm thinking, so eventually what I want to do is, for my error handling, is probably expose it through here, through this await for each. I don't know if that's a good idea or not. I think so. So essentially this main task will no longer be necessary. As long as something is doing an await for each on these input messages, then that's where the error will be surfaced. Any kind of socket error for error handling. Okay, so we've done the stream of messages for incoming messages. And actually our client socket is not doing an await for each right now, or our client application, I should say. So that's a good point. This one's not doing it. We need to start adding some processing over here for listening to messages from the server. But first, let's try this out. Okay. And of course I closed my window over here. Yeah, this is my naming. I named it TCP chat and chat server. That's my bad. So let's do chat server.exe and run the client locally. Run the client in the debugger. Keep saying that wrong. All right. So it's still connecting, still sending a message, properly framed and everything. Our server's still reading it, and there's no way to send another message. Let's do that. Let's do just a little bit of work on our client here. Okay, so this is, we're jumping back into WPF here, and it's been a while for WPF. Let's see, if I want something I can write in, then I want a text box, not block. All right, perfect. So I'm just going to say, so this button is now just going to connect. I'm going to have another button to actually send. So here we go, send. And I'm going to just make this header server. And let's jump to this code behind here. Okay, let's move this up here so it doesn't get lost in the lost in our private methods. So we've got this connecting, it connects, and then we create this chat connection, which is what we actually want. We don't want this client socket here. We want a chat connection as our local all right. So after we've created the socket and connected it, then we create a new chat connection, and this one's now going to be a local variable. And this part over here does not get done in the connect button anymore. Now we have our separate send button. So this is going to be synchronous. I'm completely ignoring, the proper ways of doing asynchronous and data binding and all that stuff in WPF. Might get to that. No promises. So we're just going to do this. Actually, I'm going to say chat connection is null. Then I'm going to say a log no connection. You can't send without a connection. I'm not even doing like disabling buttons or anything like that right now. So let's see. Otherwise, we can send a message on this chat connection, and instead of the hard-coded hello server, we're going to take, I didn't give it a name, did I? Whatever's in this chat message box. Sure. That should work. Oops. Chat message text box dot text. All right. So now I'm creating a chat message, sending it out over the chat connection, the existing one, and now I can send multiple messages. Let's see how well this works. Let's build it and start up our server, and now we can start our client. Now the connect should actually just connect, and then we have a separate button here to actually send. So I can say connect, I can send a message, and that gets hello server, and I can change this to be whatever I want. and send that. And that message also gets serialized and sent over the wire correctly. All right. I'm just going to add to the log there just so that we can see everything. When we send this, I'm just going to say that was helpful. Sent message with the chat message text box.text. All right. So now I've got a, I like that. So now we can receive multiple messages. They're coming in from the server side. Now from our application, it looks like a very nice IAsyncEnumerable. So that's a pretty nice, pretty nice development. All right, I like that. So we are now reading as an IAsyncEnumerable. Now we also, pipe or API symmetry. My next, \n at the end, thank you for the logs. Yes, because otherwise they're going to start filling up that, that text box. Thank you. Thank you, Freddie. So let's see here. So API symmetry, what I really want is the ability to write to essentially write to a stream of messages is what we want. Let's see. So right now with this send message, I'm just tossing it into the pipeline in a way that is not thread safe. And we're going to need that. As soon as we have, think on the server side, we're going to have like one client gives us a chat message and another client gives us a chat message at about the same time, but we're going to like broadcast both of those chat messages to everyone else who's connected. So like a third client who's connected would be getting a message from one client and a message from another client. And so on the server side, we're going to want to be calling SendMessage in a way that is thread safe. That allows the server to say, send this message and then send this message without necessarily waiting for the first one to complete. So in order to do that, we have to have either locking. I mean, you can lock. That's one option. The other option is to actually have like a queue, right? So when you send a message, it goes into the queue. And that way is more logically similar to how the socket send buffer already works, right? When you send a message, like a socket send, so you're not sending a message, you're sending bytes. When you're sending bytes on a stream, on a socket stream, that just gets copied into the send buffer. So I think we're going to take that same concept and apply it here and say this send message actually just sends it to an in-memory queue that then, our buffer, essentially a channel of outgoing iMessage types, and then we're going to send that to the pipeline eventually. All right, I think that's what I want to do. So we end up with an outgoing queue as well. Again, that API symmetry. The other option is I could just toss a semaphore on this, semaphore slim, and say, well, you have to asynchronously wait so that not everything is using the pipeline socket at the same time. But I'm thinking, especially with this flush async, I think it would be simpler to do it as a pipeline of sorts, or a queue of messages. So a channel, just like what we have for our input channel, I'm going to do an output channel. All right, so let's do output channel equals channel.createBounded. Again, has to be bounded. Doesn't have to be big, but it just has to be bounded. So I'll just make it the same size. That's fine. So this can have 4 outgoing messages that are waiting on the pipeline, which may be waiting on the outgoing socket buffer. So we can get that back pressure all the way through, and your send message may not actually complete if all those buffers are full. I mean, may not complete immediately. So let's see. What we're going to end up doing, we currently have a pipeline to channel. Now we're going to need a channel to pipeline. And then this send message is just going to toss stuff into the channel, the output channel. So what I'm going to actually do here is say channel to pipeline. We've got another main loop of sorts. So this is going to be, I would say while true, but actually what we are going to be doing is handling, we'd want to handle completion here too. So I'm going to do an await for each. Var message in outgoing messages, reader.read all async, yes. So now I'm reading from the output channel. I'm going to take all of those messages and I'm going to just copy this data, or this here. We know how to encode the chat message. This is all converting it into that, all right. And since this is the only code that I'm only going to have one thing reading from this output channel, and that's going to be this main loop right here. So I don't have to worry about synchronizing access to this to the pipelines in this pipeline socket because this is the only thing that's going to be using it, and it's only going to operate on one message at a time. So this is fine. The fact that the channel is in between these actually makes this thread safe, and the fact that I only have one reader. Okay. So we're reading all of our messages out, flushing, and then when I'm going to say for completion, I haven't talked about closing the socket or anything like that yet. I don't know if all the code even is there to support that, but what we're going to want to do is plumb through some of this stuff, including I'm going to want the, so when this output channel is essentially marked completed, well, we'll cover that when we cover it. So essentially I'm going to do it now. That's me, because I know I'm going to forget. So when this output channel is completed, I want to actually say, essentially pass that along. So this output pipe gets complete. Okay. Haven't talked about errors yet, so this is where we'll have to revisit some of this. But essentially that gives us a way to mark a, and I don't know if that's piped all the way through, right? So if this output pipeline, did I do that with a pipeline socket? Let's just take a look. So this is the pipeline to socket async. The question is, when this pipeline finishes, when it's complete, does it actually close the socket? And yes, it does. Okay, so I already wired that up. All right. So when the pipeline is completed, then it closes the socket. When the channel is completed, we're closing the pipeline down here. All right. So now we just have, I'm not even going to expose that yet. Now our send message doesn't need any of this code. Now it's just literally output channel .writer.write async. Now we're just passing that message into our queue from the send message. Okay, so now we have an input channel and an output channel on this type. So Freddie asks, if there's nothing in the channel, is it going to suspend and stay in the for each? So if there's nothing in this channel, then this here doesn't actually, well, the read all async completes, but you end up with an IAsyncEnumerable, which means it's going to await here for the next message. So when a message comes in, it does this processing, it does the flush, loops back around. If there's not another message yet, it will asynchronously wait here in this await for each. It will asynchronously wait at the top of this loop for the next message to come in. All right. Let's see. So this is a pretty good point. We've gotten now this isn't just doing the protocol, right? Now we have an appropriate, like a stream of messages. And again, it's you could say it's bidirectional. I think of it as two unidirectional streams. We've got incoming messages and outgoing messages on these channels. So now this is a good place here, I think, to stop for today. Actually, let's run this, make sure it still works. It seems like we're doing a lot of work not to make any progress, but as our application grows and we're going to add other message types and do other more advanced things, this is an important this is important work to have ready for us. Let's see here. Let's run our server. Let's run our client. And I can, so if I hit send first, there's no connection. I can connect here, and then I can say hello, or whatever. All right, so that looks good. We are now having an outgoing queue as well. So I want to talk a little bit about things that we haven't done yet, and things that I'm planning to do for the rest of the series. Let's see. So, all right. I figure out how to, oops. All right, wrong app. There we go. All right, so so there are some things that I still want to address, and that is I want to. So we have a stream of messages now. That's good. Today we fixed our problem with the pipeline possibly not being big enough, and then we added our stream of messages. Now what is still not here is proper error handling, right? So for the socket errors. We also haven't done anything, well, I've done a little bit of code around how to close a socket. And yeah, so I'll discuss that more next time. Today's Thursday, so I will be back Saturday probably. So next time on Saturday, day 6, I will be talking about proper error handling. We're going to get all that code in. We're going to talk about closing the socket, what we want that to look like at our higher level API. Then we're going to move into keep alive messages, which are very important when you're talking about TCP/IP protocols. I haven't discussed it at all yet. I'm hoping there's a tool called Clumsy, and I'm hoping that I can use Clumsy to demonstrate the need for keep alive messages. I haven't actually tried it. If it may not be possible to break a local client, a local host application. So I should probably try that before the live stream. Make sure I can break it first, so to show the need for it. I will do that. And then we're gonna start making this into a real application a little bit. We're on the server side. We need to start keeping a list of our client connections, and that's got to be a thread safe list. We need the ability to broadcast messages from one client to another, and then I'm going to eventually. This is probably still several days in the future. I'd like to eventually get to the point where we have messages that support remote responses. So right now it's all just broadcast. Here's your message, blah blah blah. What I want to do is get into a command reply kind of scenario, because that's very, very common in TCP/IP applications. And everything that I've built here has just been infrastructure, getting ready for the complexity that is still coming. So all that is still to come. This is taking a lot longer than I thought, but all right. Thank you for hanging out, and I will definitely push the code. Freddie, thank you. I will definitely push the code right now. Thanks for hanging on. Next time, we're going to dive into error handling and closing and see what that looks like. We'll see you then.